Hello students. So in last lecture we discussed how to draw various position time and velocity time graphs for given cases of velocity and accelerations. In this lecture we are going to explore in detail what all the variables we can calculate by given details in position time graph. So we'll start with position time graph. Here you can see a position time graph. Suppose a graph is drawn like this. So what details you are getting from this? The first detail which we are getting, I'll show you with different colors. So first detail which we are getting is that particle is starting from origin at t is equal to 0. So first thing which you will get to know that at t is equal to 0, position of particle is 0. This graph may have started from this point or from this point, hence at t is equal to 0 particle will have different positions. So we can get initial position by position time graph, that is the first point. Second point is the inclination of graph. Suppose if you will draw if you will calculate the angle in anti-clockwise manner like I had calculated starting from time axis, then this angle is known as inclination. So theta is known as inclination, and this inclination can give you the velocity of the object for straight line case graph. In straight line graph, velocity is equal to tangent theta. So this tangent theta is giving you velocity if this angle is constant. Suppose this angle is 60 degree, then velocity is going to be tangent 60, that is root 3 meter per second. If you will continue to apply this knowledge, then you can easily estimate in position time graph. If you are having a parallel line, which yesterday we discussed was for stationary object, you can also observe that theta for this case is 0 degree, hence the velocity is equal to 0 meter per second. So the point about position time graph is tangent theta, that is also known as slope of the graph. So you are also noticing one thing, that tangent theta is giving you vertical axis variable divided by horizontal variable, and in this case you are observing that our vertical variable is position and our horizontal variable is time, and position by time is velocity. Hence tangent theta is giving us velocity in position time graph. Now this was for constant velocity. What about positive acceleration in which velocity is increasing? You can still infer it that in position time graph, which is the third case I am discussing, for positive constant acceleration, positive constant acceleration, in second case, this is the case for constant positive velocity, this is the case for zero velocity, and this is the case for increasing velocity. So for increasing velocity in position time graph, you will get a graph like this. And if you will observe here, what is the role of slope here? So you can see that inclination is increasing. How can we say inclination is increasing? Consider this point in graph. Considering this point in graph, how do we measure the inclination now? Because it is a curve. So at any point, let first a point. So we will imagine a tangent at a point, and we measure the inclination of this tangent. So this is going to be theta a, which is the inclination at point A, and the velocity at point A is going to be tangent theta A. Now move little ahead and reach on point B. What is the velocity at point B? Again we will draw a tangent at point B, and we can see that at this tangent the angle theta B is greater than theta A. So velocity at point B is equal to tangent theta b. And as it is very simple that for theta b greater than theta a, tangent theta b is going to be greater than tangent theta a, which in turn tells you velocity at b is greater than velocity at a, which simply saying that acceleration is equal to positive constant increasing, or it may be positive increasing, but that is not the case in your class 11th. Acceleration positive constant is the main case, and we'll use equations of motion for that. So you can easily observe from position time graph that velocity is increasing because inclination is increasing. And please note one more thing in position time graph, case 4 position time graph. As we all know that inclination is giving us velocity, and we know that tangent 90 degree is equal to infinite. So position time graph cannot be a line parallel to position axis, because this means inclination is equal to 90 degree, which is representing infinite velocity, which is not possible. Hence, in position time graph, a line parallel to position axis is not possible. Also, in position time graph, if we are having a graph like this where this is position and this is time, and we are having a graph like this, again this graph is also not possible. This graph is again not possible because as the particle is moving from point A to point B, and you can see that time is increasing. Now particle cannot move back from B to A as time will not come in reverse direction. So this is also not possible. So these are the 5 cases for your position time axis which we have discussed so far. So in which you have seen that if I'll give you a brief revision, that in position time graph, tangent of inclination gives us velocity, and for parallel line to time axis theta is 0, which is indicating stationary object, and velocity is equal to 0. Tangent theta is giving us always giving us vertical variable divided by horizontal variable. In case of position time graph, it is position divided by time, that is velocity. Then for positive acceleration, or we can say increasing velocity, you can see that inclination is increasing continuously, and hence the velocity is increasing, which is giving us positive acceleration constant. And increase in angle means increase in tangent and increase in velocity. Then I discuss with you that theta is equal to 90 degree is not possible because tangent 90 is infinite, and infinite velocity is not possible. And also that in position time graph, any graph is not possible in which time is shown to flow backward, as arrow of time is always flows in forward direction. So after discussing these 5 points, in second part of this video we are going to discuss the same things about velocity time graph. So let us consider a velocity time graph, and the first case of velocity time graph, this is your velocity time graph. So first of all, for stationary object, as I discussed with you yesterday, that all stationary objects will have graph on time axis indicating zero velocity. So this zero velocity is indicated by a graph which is plotted on time axis, which is indicating 0, because this is the 1 v 2 3 and the values of velocity increasing in the upward directions. And similarly, the constant velocities can be represented in velocity time graph in this manner: velocity time graph, and I will also draw it for negative side. So let us say +1 +2 +3 and -1 -2 -3. So this is +1 +2 +3. Let velocity be in meter per second. This is -1 -2 -3. So This graph is indicating plus 1 meter per second constant velocity, and this graph is indicating plus 2 meter per second constant velocity. Similarly, minus 1 meter per second constant velocity, minus 3 meter per second constant velocity. Same like position time graph, we can also have inclination in velocity time graph. So third part of velocity time graph, let us have the same manner velocity time graph, starting from the graph which is a parallel line to time axis. Like we discussed in position time, theta for this graph is equal to 0, and inclination in velocity time graph is theta is equal to 0, and the slope will become tangent theta. So slope in position time graph was giving us velocity, but slope in velocity time graph will give us acceleration, that is the change, and that is very important, you do not forget this. So here you can see theta is equal to 0. So theta is equal to 0 means tangent theta, tangent 0 is equal to 0. So acceleration is going to be tangent 0, that is 0 meter per second square. So it means in all these cases, you can see in all these cases your theta is equal to 0. Doesn't matter whether velocity is plus 2 meter per second or minus 3 meter per second, the velocity is constant, and velocity is constant means acceleration is equal to 0. So that is a very important. In position time graph, we only had velocity when we calculate slope of position time graph, that is tan theta. While in velocity time graph, we not only calculate acceleration by having a slope of graph, we can also calculate displacement. So at number 4 point, I will tell you how velocity time graph also tells you about. So again, let us have this velocity time graph. In this velocity time graph, let's suppose you are having a graph like this, and if you will calculate the area under the graph at given 2 points, say t1 and t2, and I'll show you the area with red color, then this area represents displacement. So area under graph is representing displacement. There is no such thing in position time graph, because area under graph gives you the product of variables. If you are taking area under graph, it is giving you product of vertical variable into horizontal variable. And in velocity time graph, vertical variable is velocity and horizontal variable is time, hence area is giving you displacement. And as we know, in position time graph, position into time is not giving us any particular variable, but position divided by time gives us velocity. So concept is very simple. Slope of any graph gives us ratio of vertical variable to horizontal variable. In position time graph, that is velocity, and area under graph gives us product of variables. In position time graph, position into time is nothing, so we don't discuss about area of position time graph. But in velocity time graph, both velocity divided by time is acceleration and velocity into time is displacement. So in velocity time graph, by having knowledge of slope, we can calculate the acceleration, and by calculating the area under the graph, we can calculate displacement. And this displacement can also be calculated very easily if we consider this diagram into two parts, where one is triangle and the other is rectangle. This is the basis of driving equations of motion using graphical method, which we will be studying in class 11th, because you will study your integration method of calculating area under graph in class 12th. So you will first drive your equations of motion like you derived in class 9th. All three equations of motion can be derived like this. So that is the end of discussion for today's lecture. In next lecture we will study about relative velocity in position time graph, and we will also practice one or two example numericals, and then this 2A chapter is over, and we will start with uniformly accelerated motion, that is your chapter 2. Thank you.